Hi all. In this section of week one's discussion, we'll go over NumPy, Python, and Pandas. But before I get started, I will show you how to access Google Colab. So first you go to Google Colab, and then you can click this one or whichever one that pops up, but it has to be like the actual Google Colab. And then you click Open Colab, and then click New Notebook. And then that will give you the notebook. We call these like notebooks. And then you can run your code here. And that is like how we're going to proceed with the Google Colab in this class. But before I actually get started, I will show you guys the copy that you all will receive. So this is like the student version. And so here there's like more readings and like instructions if you like run into any errors. And then there's also like what we'll be going over. There's like little comment sections of what each cell is, and then just like recaps of what the following cell would be. And so you'll receive this on your Google Classroom. But if you have any questions, feel free to email any of us or ask on Friday. And then let's get started. So first, I guess we'll just name this notebook like discussion one, the course name. And so, like a brief intro, I'll just like show you all here, kind of like a brief intro on like Python, the language. Or I'll leave this page here for now. But Python is a scripting language used for programming. We'll use Python in this class because it is widely used in all fields for like machine learning. NumPy is a Python library that makes working with numbers and data much easier. It is used as a tool in university like machine learning courses, and it is popular in a world like in actual industry and research. So that's why we'll be using it here. NumPy helps store and manipulate large amounts of number efficiently. And then the main computational power of NumPy is that it uses like arrays, which allows us to perform mathematical operations super fast. And so in this discussion, we'll show you like examples of that and then how to really get started. Pandas is also another Python library that we'll be using. And the pros of that is that it's also good with like data manipulation and analysis. Specifically in this discussion, we'll be like showing you the data frame data structures, which will be very useful for your projects and in future, like your future projects. And then so let's start here with like Python introduction of data types. So I will comment this as a text. So you can drop down here as like a text. And then to actually, before I run anything, to actually run anything, if you have a Mac, it's command return. And then if not, there's also here, like if you have other computers. But let's get started with this. So let's title this like Python like intro. And then this section will be more about like plus another text, floats and integers. So an example of integer would be like x equal to 8. And so here, 8 is the integer and it's set to the variable x. So whenever we want to set something, the left-hand side will be what will be the name of like what we set it to, and the right-hand side would be like the equation or whatever we want this variable x or other variables to be set to. And then we can print the type of x. Like after we set it, and then we can print it to make sure that it is as intended of what we set. and the type. So as you can see, it printed 8, which is what it was set to, which is what we wanted. And the type of what 8 was is an integer, which makes sense. And then now I'll show you floats and decimals. So for this one, let's say y is equal to 2 over 5. And so what we know is that 2 over 5 is equal to 0.4. But what is actually 2 over 4? What kind of data structure is it? Or type? We will see that here. So 0.4 is actually a float, which is different from an integer. So the main difference between integer and float is that integer are like whole numbers. They are whole numbers. And then float are ones with a decimal. That's like a short way to think about it. So what if we wanted to combine an integer and a float? Or in other words, what if we want to add an integer, like for this case, let's say 8, and then the float would be 0.4. What would the type be? So as we intend, 8 plus 0.4 is 8.4, and the type is actually a float. That's because if we add an integer and a float, then it's not always necessarily the case that it's a float. However, because this is 8 and this is 0.4, so it's 8.4, which has a decimal, and so it's a float. And then now I'll get into strings, which I will put a text here to denote that we'll be moving on to the section of strings. So to represent something as a word and not like a manipulative number, we'll use double or single quotes. They're the same thing. So for example, let's say we want to combine the two words FOML plus 101. Like we wanted FOML and 101 to be in like one line. We use quotes. However, if we had this, you can't do this. You'll run into an error because you can't combine a string with an integer. So when we say 101, we need to convert the integer 101 to a string 101. And so now you will not run into an error and you will get like the concatenated of FOML and 101. Concatenate means just like putting two strings together. And then we'll go into Boolean next. So Boolean, they're binary variables with two possible outcomes, true or false. So an example is, let's say we set a equals to 2, which we know that to be an integer. I'll denote that here so you remember. And then let's say we print a is equal to the string 2. Take a moment to think about what this will happen. So remember 2 right here, or what a is set to, is the integer 2. But then here, 2 is a string. So is integer a string? Let's see. No. And that makes sense because an integer is not a string. There are two different kinds of data types. That's why this is false. And so by using this double like equal sign, it's like checking if two items, or you can actually have more items, are true or false. And so that's what Boolean really does, is kind of give you a true or false. Let's do 3.5 is equal to 7 over 2. And so we know that this is true, but is this really true in like what the computer reads too. Let's check that. Yep. And the reason being is this one will return a float, right? And this one is a float. So that the data type checks out. And then are the like values of the data type the same? Yes, because one would return 3.5 and it's 3.5. That's why it's true. Let's say b equals to 9, which does not equal to 9. So what this one does is you read it from right to left because b is what this is, like the value of this Boolean is getting set to. So the exclamation mark with the equal sign, that means not equal to. So this one means that 9 does not equal to 9. This is what this function is like trying to evaluate. Is the integer 9 equal to the string 9, like in words? So it's not. And so therefore, because it's not, that means it's true because this one is, does 9, so to phrase this in a whole sentence, it's like, does the integer 9 not equal to the string 9? That would be true. And so this evaluates to true. And then the true is set to this variable b. And so what you would get is if you typed out b, you would get true because this is true, and then it was set to b, and then so b was set to true, and so it would turn true if you ran b. Let us go on to list. So list is a mutable collection of data, which means that we can change it after it is created. A list can be created using square brackets. So I'll square brackets as in like this. Those are what we call square brackets. And then some important functions are like adding, like this adding, which will append items to the list. And then the length, which is like this, which gives us the length of a list. And I'll show you briefly in a couple moments of how to actually use these. But that's what we'll be going over. So when I meant adding, we can do, like for example, let's say we create a string, we create a list. So we start with this, and we got to input the items in this list. So let's say we input FOML. So we input it as a string because recall that if you just put FOML, it'll error. And maybe I'll just show you what I mean. So this is going to error because nothing was defined, right? Like, but then if, for example, here B, if you typed in B and ran it, it would not error because you defined it or set it to something. But FOML was not set to anything. So that's why it's going to be errored. And then here, let's go back to our list. So let's say we create a list. The first element, we want an FOML of string data type. And we also have another list, which is with elements 1, 2, 3. Let's say we want to combine these two. So if we just combine it and not set it to anything, then it would mean nothing, right? So let's say we let it set to L, and then let's return L to see what it actually created. And so that's what is meant by adding in order to like append these items to this list, which will result in the combined list of all the items in the second list to the first list. And then to check the length of L, which the length means how many items are in this list, this combined list. So we count, we have 1, 2, 3, 4, right? But for bigger lists, you don't want to do that. And just to compute it, you can actually do length of L, and that will give you I'm sorry, this one is in text, not code. So this is how you delete it. So length L, it will return 4. Sorry, not one, L. There you go. Okay, L. So here we go. We get 4, which is as intended because there's 4 items in this list, which the list is L. So that was kind of the brief intro on Python. Now we will move on to functions and variables. And so what functions are, I will separate these in function. Okay, so function, they can take on several arguments or inputs and return an output. So Python has some built-in functions. So for example, let's say this function absolute value. So what Python has built in is the absolute value function, which you can call it by like typing in ABS, and then these parentheses inside is what you want to input into this function. There are like thousands of built-in Python functions, and you can just do like a Google search to see like what already exists, so then you don't have to create your own functions. But if you do, don't worry, because we'll teach you how to actually define your own functions. So for example, this function absolute value, what it does is it should, let's say you have a number, negative 51, it should return 51 back to us, right? So let's check if it actually does. Yep, it works as intended. And then so now let's say we want to find the maximum value in a list. So let's say we have this list containing 1, 0, 2, and -9. So looking at this list, we know it's 2, but let us just like convince ourselves that we can like really trust like Python built-in the function. So let's see, does it return 2? Yep, it works as intended. So as I mentioned that if Python library does not have the built-in functions you want, you can create your own functions. So now I'll get into like what we call user defined functions. So for this one, let's do a simple example. Like let's define like a function that can add 2 numbers. So you give it 2 numbers and then it will output the sum of those 2 numbers. So to actually first define a function, you would write define. That's like how it's supposed to be written, is you write def, and then the function name. You can name this anything you want, but let's just name this as add numbers, just so it like relates to what we actually want it to do. So we can put x plus y. And so what this does is this was our name. This is what we name it. And then this is, sorry, not x plus y. We wanted to do x plus y, but it takes on 2 arguments. We call these arguments or inputs is what the user will input into this function and then output some things. But the user does not see what is like actually written inside, right? So to actually do what I want to do is you want to type return x plus y. So this will do is add 2 numbers together. Let me write a comment of that. This is how you write comments, use the hashtag, and then you can just type. So maybe I'll also write a note here. The inputs are x and y, and then defined function name is this one. So I'll just copy and paste that. So it returns the added numbers of x and y. So here we defined it, a function. We name it add numbers. It takes in 2 arguments, x and y, and it'll return x plus y. Because if you recall, you can actually add 2 integers. So this works. And then we can try it out. We'll run this first. We'll add another line. Here, let's just copy. Let's say this, right? So to actually call this, you can just call this function name, which we have defined it in the previous cell. So to use it, you just type in the function name and then any two numbers. Let's just do 1, comma 1. So we know that 1 plus 1 is 2, but did we write our function correctly? Let us double check. So this should return 2. Yep, it did, and it's working as intended. So you have defined this function as you have intended. Or maybe now I'll move on to like a function that is with a little bit more like more written stuff. So here, let's define a function. I'll like make a comment of what we want to do. We want to round a number to the nearest integer without using the built-in function. So here, let's say we say round number, and it takes in a number. So let's just name it number. You can use anything. You can name it X or anything you want, because it's just like the argument. It's just to denote like how many arguments that is going to be taken in by the function. So let's say the integer part is equal to the number, which is what the user will input, 1, and then the decimal part would be the number subtracted by integer part, because like what is left over would be the decimal part after doing the like division. And then so if decimal is greater than equal to 0.5, the integer part would be plus equal to 1. So plus equal means that 1 will be added to the integer part. That's how we do addition to current set of values, is you do plus equal. And then once this is ran, or if this is not true, then it just returns the integer part. We can just do that. And so let's say, for example, we want to try out the round number. We'll use this function, the round number that we just made. Let's round 3.1415. Let's see. And it goes out 3, which is as intended. So here, note that this inequality means that this decimal has to be greater than or equal to 5 for this inside part to run. If this is false, so if the decimal was not greater than or equal to 0.5, so for example, if it was like 0.1, then it would just return the integer part. It would exit this if statement immediately. However, if this is true, then it would enter this and it will run this part, which the integer part would just run as plus equal to 1, and then it'll have to exit this. Once it exits, it'll return the integer part. So that is what this defined function is doing. So we have covered so far user-defined functions, list, boolean, string, float, integer, and this is the Python intro part. Now I will get into NumPy. So to actually use NumPy, which is a Python library, we have to first import it. Or actually in any library that you want to use, you have to import it. So we will import NumPy. This is how you import libraries, is you write import the library name and as like something else as NP. It is standard to use like import NumPy as NP. That's just how it's used throughout the whole world. So we will be using it like the same format. and same like phrasing as NP. Though you can name anything else, but it's standard to do it that way. So we import it, and then now we can use all the functions, the built-in functions that this library package NumPy has. So as saw in the previous section, we know how to create lists, but the whole point of NumPy is for its like data manipulation by using like arrays, the structure of arrays. And so to actually, like if you had a list and you want to convert it into an array, you can actually do that. So let's set a list as 1, 2, 3, 4, 5. Let's set that list to 1, 2, 3, 4, 5, and let's make sure it's putting out a list as we want it to. Yep. And then how do we actually convert this list into an array? So what you would do is, let's name this my array. And then we want it to convert this list into an array. So to that, you call the package and NumPy. So you renamed it as NP. So you call it as NP dot, use like dot to call a function that is built into the package. So to access it, you just call dot and then the function name. So you call dot array, and then the argument or what you need to put in is what you wanted to do in this case is you want to convert the list to an array. So you put that list into an array because this np.array function, it converts a list to an array. So yeah. And then to actually see, you can print what this was set to. So you can see here, it prints an array. So the huge distinction you can see is commas. Lists have commas that separate each element. However, an array does not have commas that separate each element. And then here you can also check the data type to make sure it is as what you intend it to be. So here, let's just do that. And then print the type of my array, which is my array is this. So you should expect this to like give you the type, the class type, which is array, right? Double check that. Yep, it's intended to do that. So you know that you have successfully converted a list to an array data type. Let's work with an example of actually the possible like functions in this NumPy library aside from like converting list to array. So first let's do round. So there's actually the like NumPy has a built-in round function, so we'll use that. So for example, let's say the float, let's use 3.1415 again. And then let's name this the rounded number is equal to np dot. We want to round, and so the built-in function is round. And then the float or what you want to round, which was set here. And then you can print the result of the rounded number. And so we should expect it to be 3 because the round, you round 3.1415 to its nearest integer. And so you get 3. And then we can also perform like array operations with the np dot array. So let's first initialize 2 arrays. To do that, recall that if you set the left-hand side to the variable name, so let's say that's A, so let's call that A is np is equal to np dot array, and it takes in like, for example, let's say you had a list 1, 2, 3, and then B is np like 4, 5, 6. So let's first initialize these arrays. So I'll write a comment here that says initialize array. So this is done. Sorry, I mistyped this. There we go. And then we can perform like element-wise addition of 2 arrays. Let's say in this case, it's A plus B, right? So that's what we want to do. So element-wise addition means like the element 1 of this array, let's say A. I'll put a comma, maybe that'll be easier. or easier to distinct the two. So here it means element 1 of the first array, array A, plus the first element of array B, which is 4. So element-wise addition of two arrays. In this case, we will intend this to give us back an array that is of 1 plus 4, which is 5. That'll be the first element. Second element, we will want 2 plus 5, which is 7. And third element, we would intend it to be 3 plus 6, which is 9. So to do that, we can try. Let's see what that would look like. A plus B. So if we added two arrays, it does element-wise addition, which does that. And then let's say we want element-wise multiplication. I'm just going to copy and paste that. Which means if we did like the star symbol times B. So it would be the first item times the second item in the second array. So, like here. Or third item times the third item and the third item in the first array times the third item in the second array. So here we run this, we get it as intended. 1 times 4 is 4, 2 times 5 is 10, 3 times 6 is 18. And then to access elements in an array, let's say access element in an array. Let's say, for example, we want to access the first element in my array, which recall my array is this array. So you would actually do my array and use these square brackets to get the element. And so we put 0 to get the first element. So when counting in arrays, the first element, or what we call the first element in words, is 0. And the second element is 1. Third element is 2. So counting always starts from 0 when counting, like when getting the values back from an array. So here, my array, first element, we know it's 1. And so the computer reads it as my array, get the 0th element, which is 1. And then now we can move on to aggregate functions for arrays. And then we'll also be using my array is equal to this following array as a standing example. I'll leave it here so it's like for y'all to remember what the my array stands for. So we can perform sum of elements in an array. So what that really does is like, given an array, all the elements will be added together. So you call np dot sum and then my array, because you want the elements in my array, which is this array, to be added together. And then so 1 plus 2 plus 3 plus 4 plus 5 is 15. So let's double check that. Yep. And let's do like the mean. So you can print out np dot mean and then my underscore array. So this one calculates basically the mean of these values, which is 1 plus 2 plus 3 plus 4 plus 5 divided by 5. And so we should get 3, and that's what it outputs. There's also like max, min, median, and a lot of other built-in like aggregate functions in this notebook that will be shared with you. Like right here, you can try these out yourselves, or like even Googling like some more functions because there's a lot, but not all of them. Yeah, I will not show these here since it's the same idea. The idea is just calling numpy with np and then dot and then the function name and then the my array. That's the whole idea of this section. And so here now I'll actually show you all like what the main distinction is between arrays and list. So I'll copy this. So we know like we're on the same page about what section we're on. So the main distinction is that NumPy supports element-wise operations. So what that means is like here, like for example, here we did A times B. So it goes like element per element within like the two arrays and then performs operations. So if we had like for example, one single array, and then we wanted to multiply two to every single element in that array, then NumPy would be like you would use NumPy's like array and not use a list because the list will actually return out something different or not as we thought it would intend to do. So if you want to multiply every element in this array by 2, you can just do array times 2. Let's see what happens. Yep, that's exactly what you want it to do. However, if you had a list, let's say 1, 2, 3, 4, and you did list, so let's say you print out this list times 2, you would not get this, which is what you wanted to get, and instead you will get a duplicate, which is basically the exact copy but extended of the list itself. So as you can see, element-wise operation is very helpful with arrays. And so that's why we'll tend to use arrays for like data manipulation and not lists, because you get very different results. And that caps up the NumPy portion. We will now move on to pandas. So pandas is really designed to make like work easier with structured data. And then the most notable one is with the data frame structure, which I'll show you in just a quick moment. So to import any library, just like how we imported NumPy, you first type in import the name of the library, which is pandas in this case, and as PD. So PD is standard name of pandas used like the whole world. So that's why we'll be using it here too. Run this. And now you're good to use all the functions in the panda library. And then let's do an example. So this example it's strictly from here. So I would not type this all out, but I'm just going to copy this. So what this is a dictionary. So here you just create a dictionary which stores like key value pairs. So think of an actual dictionary where the key is the word you may be searching for, but in this case, it is the column name, which you have column names of name, age, distance, time, interested, and its values are like the definitions of the words. But in this case, the values are the data or like the data of that group that it belongs to with respect to the column name. So like name would have all the names of the participants, their age, distance, and so on. However, like Kayla doesn't mean that. Kayla has all information of these, but instead, what this really corresponds to is Kayla is age 18, ran a distance of 5 kilometers, took 30 minutes, and is interested. That's how like it's stored. And so we will actually see how it's stored by using the PD or pandas data frame to visualize it. So let's name that as data frame DF. You can name it anything you want, but we'll name it as DF for now. And then you call the data frame function, and then you give it this dictionary, which we called as data. And then let's see what we get or how this would be visualized. So this is what it means. So here, as I mentioned, the Kayla age 18, so it'll be read as in rows. So the user or whoever would collect data in rows, right? However, when you want to do data manipulation, you don't really care about these rows so much. You care more about like column wise. So that's why all these using this, like converting it to data frame would help with actually data manipulation with it being in uh, like a tabular form if you want to visualize it more. In future classes, we will not be using dictionary, but this is just like a short example of like a shortened kind of data set. But in future, you'll either be importing something online or using like Google Sheets or Google or Excel to have already a pre-written like data set for you, and you just need to import it as a CSV, a comma separated value. And so import that, and then you can just put the whatever import it is into this argument of the data frame, and then you are ready and good to go with manipulating that data set. And more on that you can read here on like importing a CSV, or maybe it's not written here, but it will be shown when and for sure in the next discussion. So now let's go through a quick example of why is this such a powerful tool, right? Let's say we want to find the average time that students ran. So comment that this is our objective. We want to find the average time students ran. In average time as in like this group of students here. So right here. So to calculate this, we would like intuitively, you would go and calculate this as you find the column time, like find all the students' time and just add together divided by number of students. That's how it's done. And so you would go by like each row and then like find the time, right? So that's why what you really actually need to do is you need to find the column and add the column up and then divide it by number of students. However, there's a simpler way or a much more fast and efficient way. If compared to here, you only have 5 rows of data, but if you had like 5,000, you would not want to do this by hand. So what you do is with this data frame, df, you can call this column. So you actually have to make sure that the column name matches what you input this. So you can just copy and paste it like here to ensure that it's the same. And so here, what this does is you get the data frame and then you get all the data corresponding to this column of the data frame. So let me just run that real quick to show you what that really outputs right here. So as you can see, that is what we want to do, because what we really care when finding average time students ran is really just this group of data. We don't care so much about age, distance, name, or if they're interested, if we just care about the average time they ran. So that's why you just need to get this column. And you can get any column if you want. But for this problem, we'll only work with this column. And then to find the average, it means mean. So you can actually just call mean. It's another built-in function. To call functions, you press dot mean, and so there we go. And so this, what it should do is gives you the average time students ran, which would be, if you did this by hand, would be 30 plus 20 plus 40 plus 15 plus 35 over 5. But instead, you don't have to do that because you have this tool of Python and pandas and all the functions it has built in. And then you just need to know how to write this, and then you can just run it and it'll give you the average time the students ran, which is 28. So that's actually all the examples and like things we want to cover for this first discussion. But as a recap, we went over like Python intro with float integer, string, boolean, list, and went into function variables, and we kind of gotten used to like what is the built-in functions and then what are like user-defined functions if there aren't any built-in functions we want to use. And we went over NumPy and pandas and then really saw like why it's so powerful and like how like the different things we can possibly do with. There's so many more things you can do with it, but these are just more of the just like the scratch on the surface of really like how powerful these tools are. The Google Colab, this one will be shared with you on Google Classroom. But if you have any questions at any time, feel free to reach out to Srijal, Andrew, or I. And then next week's discussion will be on classification algorithms. And so this concludes our first week's discussion, which is an overview of AI and ML. And so see you all next Friday. Thank you.